Good morning. This is Sukanya, working as assistant professor in the department of EEE, Adiman College of Engineering. And today we are going to see about the basic sorting techniques that are carried out in C programming and data structures. Basically, when we say a sorting algorithm is used to rearrange a given array or list of elements based on the comparison operator on the elements. When it comes to comparison operator, it is used to decide the new order of elements in the respective data structure. In a simple manner, we can say that a sorting is nothing but reordering of all the elements either in ascending or in descending order. Here it is shown an unsorted list of elements and a sorted list of elements. That is for the basic understanding, that is the arrangement of elements in the ascending order. And we have various technologies that are being used in the sorting techniques. Okay, we'll see by one. The first thing is in place sorting, the second internal sorting, and then we have external sorting, and we have stable sorting and unstable sorting, right? And in place sorting, we can say that an in place sorting algorithm which uses constant space for producing the output. Okay, for this we can take an example of selection sort, bubble sort, insertion, and even heap sort. The next comes it is internal sorting. Internal sorting in which all the data is placed in the main memory, which we call it as an internal memory. The one thing is that in internal sorting, the problem, it cannot take input beyond its size. Okay, for this we can take an example as bubble sort, selection sort, quick sort, and even insertion sort. And then next comes the external sorting. The external sorting is when all the elements that needs to be stored cannot be placed in memory at a time, and this we call it as an external sorting, because external sorting is used for the massive amount of data like merge sort, external radix sort, and etc. And then we have stable sorting. It is nothing but when two same elements appear in the same order in sorted data as in the original array, then we call it as a stable sort, which is nothing but merge sort, bubble sort, and insertion sort. And then we have unstable sorting. This is when two same data appear in the different order. Whereas in stable sorting, we are saying it as in same order, but in unstable, we say it is at in different order in sorted data, and then it is called as an unstable sorting. And for this, we can take an example as selection, quick, heap, and shell sort. Okay, and then this part shows about the characteristics of sorting algorithm. This is the basic characteristics that are required for a sorting algorithm that are being used in the data structure. There is the time complexity and auxiliary space that are being used, and the stability of the algorithm that is being used, and in place sorting, and the last, it is adaptivity. And even some more characteristics can be added to this sorting techniques, that is searching algorithm, the data management that is being used, the database optimization, and the machine learning, how to prepare a data for training. And we have the data analysis, and the next part is the operating system that is being used for the sorting algorithms. Today we'll see about the basic three sorting techniques. That is, these are the three basic sorting techniques. That is, the first one we'll see about the bubble sort, second is the insertion sort, and then we'll see about the merge sort. This is the basic sorting technique, that is bubble sort algorithm. The bubble sort is the simplest sorting algorithm. Okay, in data structure, we can say that bubble sort is the simplest sorting algorithm. When we get into bubble sort, is the simplest sorting algorithm that works by repeatedly swapping the adjacent elements if they are in the wrong order. In one line, you can say that it is repeatedly swapping the adjacent elements that are present in the list. Okay, this algorithm is not suitable for large data sets as its average and worst case time complexity is quite high when compared to the other sorting algorithms. And in this bubble sort, we sort the array using multiple passes. Okay, after the first pass, the maximum element that is present in the list will move on to its correct position, that is to the end, or it's to the correct position. Same way, after the second pass, the second largest element will move on to its correct position, and so on. The passes will continue until all the elements that are present in the list are getting sorted out. And the other point it is, in every pass we process only those elements that have already not moved to its correct position. Okay, that is, after k passes, the largest k element must have been moved to the last k position. If you take one element, that it will be repeatedly swapped and it will be moved on to the its original, or we can say it as the correct position. And in a pass, we consider remaining elements and compare all adjacent and swap if largest element is before a smaller element. If we keep doing this, we get the largest at its correct position. We can see an example for this. Here in an element, this is a simple example. As we said, bubble sort, it works out for the small amount of elements that are present in a list. Right, here we have 5, 6, 1 and 3, and in the first pass we can see that 5 and 6 it is compared, and as 6 is at its correct position, and then 6 and 1 are being compared, and 6 is moved to its correct position in the first step. And you can see in the second step 5 and 1 is being compared, and 5 is repeatedly swapped to keep it in its correct position. And in third position 1 and 3, and here already 3 is in its correct position, and no swapping is required for this 1 and 3. And finally we get the sorted elements as 1, 3 and 5, 6. This is the simplest sorting technique that is being used in C programming, that is bubble sort. And next we'll see about the insertion sort algorithm. The insertion sort is one of the most important algorithm that is being used in the data structures. Okay, this insertion sort is a simple sorting algorithm that works by iteratively inserting each element of an unsorted list into its correct position in a sorted position of the list. It is like playing cards in your hands, right? When you are playing cards, or when you have it in a two set of groups, that is one set of cards with sorted set and the other as unsorted, and when you are inserting from the unsorted to the sorted, we'll keep it in a position where it comes, right? So that is the insertion sorting. Okay, you split the cards into two groups, that is the sorted cards and the unsorted cards. Then you pick a card from the unsorted group and you put it in the right place in the sorted group. We start with second element of the array, as first element in the array is assumed to be sorted. Okay, this is in insertion sort. And then it will be compared with the second element with the first element, and we have to check it if the second element is smaller, and then we have to swap it. And then we have to move the third element and compare it with the first two elements and put as it's in the correct position, and this it will be repeatedly done until the elements are sorted out. Okay, this is the iterative process. The element, it will be inserted to its correct position. Okay, and for this, here is an example. Initially the set of elements is 23, 1, 10 and 5 and 2. Okay, the first thing, 1 it will be moved onto its correct position, and then 10 is being moved on, and then we have 5 to its correct position, and the last we have 2 is moved on to the correct position. When all these elements are being done, the last 23, that element, it will be automatically moved on to its correct position. Here we have the number of passes as 4 passes is being done, and again it is the iterative process. Okay, and there in bubble sort we said it is a swapping of two elements. Okay, it will be the elements, two elements, it will be compared and it will be swapped out, and here it is then iterative process. And this is again the same process. It has been explained in the step-by-step process. The initial elements 23, 1, 10, 5 and 2, and in initial condition we have taken the 23 element, and in the first pass 1 is compared with the 23, second pass 10 is compared with 1 and 23, and in third pass we compare 5 with 1, 10 and 23, and it will be inserted in the correct position. Likewise the fourth pass, the last element 2, it will be compared with 5, 1, 5, 10 and 23, and the element it will be inserted in its correct position. And finally we'll get the sorted array as 1, 2, 5, 10 and 23. And next we have the merge sort. This is again a simplest sorting technique. Easily we can understand it. That is, the merge sort is a sorting algorithm that follows the divide and conquer approach. Okay, and it works by recursively dividing the input array into smaller sub arrays and sorting those sub arrays and merging them back together to obtain the sorted array. It is repeatedly doing the process of divide and conquer techniques. In simple terms, we can say that the process of merge sort is to divide the array into two halves, sort each half, and then you have to merge the sorted halves back together. Okay, this process is repeated until the entire array is sorted. And here is an example for merge sort. We have the set of elements as 38, 27, 43 and 10. And first, based on the divide and conquer technique, we are dividing into two groups, that is 38, 27 as one group and 43 and 10 as one group. Again 37 and 27 is being divided as 38 as a separate group, 27 as it is separate, and in this side we have 43 and 10, again it has been separated, you can see that. Okay, and now with 38 and 27 we are merging those two groups with the sorted element. Before it was in unsorted condition, and with the sorted condition we are merging it again. We have 27 and 38, we are grouped into 27 and 38 as a sorted group, and in this side we have 10 and 43. Now we have two groups again, that is 27, 38 as one set of group and 10 and 43 in the other group. And now these two groups are to be merged again with the sorting, and then finally we get it as the 10, 27, 38 and 43. And how it works is an explanation of the merge sort. That is, merge sort is a popular sorting algorithm, okay, as it is known for its efficiency and stability, and it is one of the easiest approached algorithm. Okay, it follows the divide and conquer approach to sort a given array of elements. It is the step here the step-by-step process is being explained. That is, divide. First we have to divide, that is divide the list or array recursively into two halves until it can no more be divided. That is the last element, it will be a single element. The further it cannot be divided, right? That is the thing. And then we have to conquer. Each subarray is sorted individually using the merge sort algorithm. And finally we are merging after the dividing and conquering, and then we are going for the merging. That is, the sorted subarrays are merged back together in sorted order. And this process continues until all elements from both subarrays have been merged. And again I have given an example, the same merge sort in a different manner for an easy understanding, right? Hope you can understand this, right? The step 1, the whole set of elements being grouped, divided into two groups, and in step 2 again further it has been divided, and then we are conquering, and then we are merging it. Okay, hope you have understood the basic sorting techniques. That is, we saw today about bubble sort, insertion and merge sort. Thank you.